welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Zilong, who has completed the course C++ for Robotics Basics. So we'll be seeing his code base running on the real robot to demonstrate what he has done. And without further ado, I'll now hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Zilong.
Okay, so here is my. Do I need to show what I had done it to control it in the real robot, or I show my uh code first?
I think you must show it working on the real robot first, then we can get into the code later.
Okay, so this is the real robot I had connected, and now I'm going to input my to launch it. Just 1 second. Weird.
Maybe try using teleop. So, oh, now it's moving. That's good.
But why my code didn't run? Oh, I need to write. 1 sec. Oh, I think I didn't run my code yet. Sorry.
Okay.
Where is So this is how it run. When it connect close to the blockers and I think it's 0.3 meters, and it will do a turn, and the left turn and the right turn is based on the distance. It will find the or like if the right turn is 0.5 meters and the left turn is 1 meters, it will turn left. And if there is no blockings before it, so it will move straight. And if it's have left, if it detects something on its left, it will turn a little bit right. And
Okay. Okay. So this is the class version that's running.
yes.
Okay. All right. All right.
Do I need to wait it to uh go through one,
Uh.
or this
n-
is
okay. Let's see it make a couple of more turns, right, and then we can then see the non-class version working as well. I'm assuming it's gonna produce the same effect, right? But this is pretty good. It's doing obstacle
sorry?
avoidance. Let's let it finish a little bit, or do a couple more turns until it gets to the point
Okay.
where it started. Yeah.
Okay. I think I also add a stop, emergency stop point if I press P, because that's more familiar. I always forget the keys is the stop button, so I
Okay.
set a P.
All right. So you configured your own.
Yes.
All right. Let's do. This was the class version. Okay. Let's see the non-class version working.
Okay, I will stop it. One
Mm-hmm.
second. Okay, and it's and should I unconnect it, disconnect it?
No, it's not important. It's the same code, right? So
Okay,
it's the same code base, so you should be able to run.
okay. So here is my classes, and first it has basic movement.
Let's
Uh,
see what's in those functions. Okay.
yes. So it's just uh send speed or the linear speed or the angular speed and set the rest 0.
Okay.
And so when I use this, I will also set a time outside of these functions. Be, and basically because um it's just for control, and I just do some simple tests, and it need to like I want to see if it turn right and turn left have the same angular, and I set the time to the same. And this is this function, and also it contains time movement.
How did you choose the time that you allow it to move? So let's say it it realizes that the front is free. For how
I
long does it
think
move? Yeah.
I think it's two times two boxes. So, and here I said, I, this is how to say that? Uh, um, means if I don't input anything into this function, it will be 1. But when I use it, I normally set it into 0.2 meters per second. So, and I always run in one, I think it's 1 second. Let's track.
Okay.
I
Oh,
put it, let's be 2,
okay.
and 2 seconds. Yes,
Two
here.
seconds. Okay. Okay. So
So it's,
you have a default parameter, and then you can choose to change it depending on what the file.
yes,
Okay. All right.
yes, that's default. Sorry, I forgot the
Okay.
name of it.
Okay. Okay. And then you said you chose 2 seconds as the time that it has to go for. Is that right?
Yes,
Uh,
yes. Because I think when it starts, it will in the middle of the which means the front will be 1 meter and the back will be 1 meter. So I said maybe 0.4 meters is good enough. And for the turn is like one angle. I don't want to it turn a lot or,
So what was the
or
time?
turn so fast.
Okay, so it's still 2 seconds for the 10. So when you set the angular velocity to a particular value, it has to execute for 2 seconds as well.
Yes.
Okay, all right.
This just for test. I use this to test the left turn and the right turn because I have no idea what should I input. If
Okay,
it we can say here because I for the right turn is minus, and for the left turn is
it's
for the left
positive.
turn is positive. Yes.
All right. So
So
okay, so what happens when, let's say, you set a particular angular? No, let's speak about linear velocity. If you set linear velocity to, let's say, 1, for example, right? And
yes.
then it cannot go for the 2 seconds before it gets into the obstacle. Does your control loop stop? Does it get an interrupt signal to say don't go any further because there's an obstacle or the
I think
threshold?
this is a part of the specific movement.
That's what
Like,
I want to understand from the way you implemented your code. Um do you have that interrupt happening within your control loop? Because if, let's say, you say I set an angular velocity, a linear velocity of 0. 0.1, for example, right? And you
yes,
set it for 2 seconds, right?
yes.
What if it gets to an obstacle before the 2 seconds finishes? Does it stop? Does it get an interrupt signal to stop before crashing? How does it work?
I didn't set it. Sorry, I didn't set the stop. the distance detect because I think for the time movie, I just use it for test
Mm-hmm.
and and if I run it in a real loop, I will add a stop. You can see here the P3. Um,
Which function is that?
uh, is I didn't get it. What function?
I thought you were showing me which function does that for you. So,
Oh yes, I I'm showing here. Uh, block front
okay, I see there's 10 right 4.2 seconds. Okay.
here. It will stop. Every it will stop. Yes.
Okay. All right. All right. So based on what the what the threshold distance is, or whether which side is open and which is not, it can choose to stop or move to the open side. Is that right?
Yes. Yes.
So does this mean that your all your functions that check for the different directions have an else stop, or it just happens in that one
Y-
function?
Uh, if it has nothing front, then it will go straight, and if it's totally blocked, like everywhere is blocked, it
Mm-hmm.
will stop.
It will stop. Okay. All right. All
Yes.
right. All right. That's good. So let's go to the non-class version. It's going to be
Okay.
exactly the same, right? I think, but it's good if we see it.
Yes, mostly as same.
Okay. So what's
Some
different?
It's just because I will show you here. I put something in the public it and you need to set some in function variables that so that you don't need to input the variables in functions like this. You can directly use them. And also I put something in the private so that you will not so that you cannot use it outside in the outside you can only use it inside your control because you don't want others to control your robot
Right. Okay.
to
Okay.
send the how to send the speed to change the speed.
Okay. So
Yes.
you make them private. I see.
Yes.
Okay.
And also
So
and
what we were
also
looking at, what we were looking at earlier, it was the non-class version. Is that right? The one that doesn't use classes. This was the one we're looking at.
this is non-classes.
Okay. All
This one.
right. Okay. Let's go back to the class version then.
Yes. And also I think um 1 second. I think it's more easier to use because you don't need to input the variables every time
Okay.
and it's like a global variables.
Okay. So
Yeah.
you avoid the use of global variables when you use classes, right?
Yes.
Mm-hmm. Okay. All right. That's good. So let's see one more. Can you show me your control algorithm in the class version? The one that's responsible for obstacle avoidance.
Like here.
Yes, the one that does obstacle avoidance for you. Scroll down a little bit. This one here.
Sure.
Yes, this one. Can you take me through the logic behind this function?
Okay. Sure. Uh, let me see where should I start. Firstly, I divided the lizards into 8 ranges, and I only choose the left, right, and the front ranges so that uh, because for most robot in real, I think the back is blocked. It have some like support or something like that. It will blocks the laser. And also uh, I I defined in function, and it will get minus the minus distance in that range. For example, if the front range it contains 0 0.5, 0 0.6, 0 0.3, and I will find the 0 0.3. And I found every minimum distance in different ranges, and so that I could use it to control the robot. And so here is the logic. Uh, if nothing front, this means nothing front, and it will move forward. And if front left is blocked, the minimum left is smaller than the threshold. The threshold could be changed and set 0 0.3 here. Yes, 0 0.3. And the fry sorry the right, the front right had now nothing blocked, so it will turn right.
Mm-hmm.
And turn right a little bit, and this is exactly the same, it will turn left. And so if the front is blocked, I will choose uh, where should I go, and it will compare the left and the right. If the left is have more space, I will turn left, and if I totally blocked, so it will stop.
Mm-hmm. Okay. Can you tell me something? Did you encounter cases where your robot crashed, right? When you were testing, did you come across cases where your robot crashed or did not see an obstacle? Right. Did you?
Uh, I don't meet that situation. I think I didn't like
You
party. I didn't uh test it on purpose.
okay. All right. So it just worked like perfectly on the first time. Okay. That's good. That's
Yes,
good. All right, Silong. Thank you.
because it worked well on simulation, so I directly put it on the real, and that's how it happened. Everything is done.
Yeah, yeah. Normally,
No
no,
bugs.
normally when you have it working
Oh,
in
actually, I
simulation.
meet some difficulties. Actually, I meet some difficulties. I will show you. I put some marks here.
Yeah, let's talk about those ones because that's what.
So, yeah.
Okay.
Okay. So here I add a stop time for the stop, because when I test on the simulation,
Mm.
if it didn't stop for enough time, it will have like the moment. Did I see it right? Like if you are moving forward, you can't stop immediately.
Oh, momentum.
And
Okay.
momentum.
Okay, so you're trying
And
to bleed out momentum so that it doesn't jack when it
yes,
stops.
yes.
Ah, okay.
Because when we're doing the test, and like what I said before on the P2, I test if the turn right and turn left could reach the could come back, and I found it always have some angles that make the robot turn right a little bit, so I add this stop.
Okay. All right. All right. It's a good thing that you figure that out. Um. All right. Any other one that you had to deal with using your a custom method difficulties?
And here I meet a bug that I cannot directly see how it happened, and I use GDB to locate the failure. Bec- uh, and I found uh, I'm a little bit forgot uh, what the bug is, but it seems like I need to set a private to announce the variables at the beginning, I think.
Oh, was it not a problem of initializing your variables?
Yes. And also here is really interesting one, because at first I what I write is 5 divided 8 times the number of ranges, and I always got 0. And
Mm-hmm.
I suddenly realized it's because this is this function will only return the uh, in, uh, int int number, so
Mm-hmm.
that you will calculate 5 divided 8 first, and I will got a 0 or
Mm-hmm.
1. Uh, yes.
Mm-hmm. Okay, so you were trying to divide,
Yes, it will got 0 because it will down to
truncate.
the yes.
It would truncate the the number that's not zero, right? So that which is after the decimal point.
Yes. So I trained it into the big number, and I at the end I divided.
Uh-huh. Okay. Okay. I see. All right. Yep.
I think I think maybe I should add a rain add how to say that I think it's round
Or
function.
round down, round up. Or
Yes,
okay.
because yes.
Yes. So exactly that would have probably worked because then you're not dealing with floating point numbers anymore, right? You get integers
Yes.
every time. Okay. All right. All right.
Yeah.
All right. Thank you very much for your presentation, Zilong. So,
And
go ahead. You wanted to say something?
yeah. And also a function uh not here, and also at the beginning uh there is a function I need to put it here before it's used. So I define it at the at at below, and I also declare it at the beginning.
Hmm. Okay, okay. I'm still trying to understand why that had to be done, but it's fine. Anyway, we are out of time, so we'll wrap it up here. All right. Warm congratulations to you, Silong.
Yes.
So just hang around for me so that we can
Thank you.
wrap it up. Okay. All right, everyone. This was Silong's presentation, and warm congratulations to him. Would like to encourage all those of you who would like to give a shot to this course, and you can come and showcase your work. And until next time, we encourage you to keep pushing your learning. Bye bye.